Bio-Clim-Land Centre of Excellence. Centres of Excellence at National Research Tomsk State University are advanced research platforms working in the university's priority development areas. 5 such centres were established as part of the TSU Competitiveness Improvement Programme and fixed in the TSU roadmap as key drivers of progress. Bio-Clim-Land Centre of Excellence is one of them. TSU Bio-Clim-Land Centre is a multidisciplinary research cluster working in the field of life and earth sciences. Its research activities lie within the priority areas of both Russian and world science. 2 leading scientific schools in the fields of botany and landscape ecology, supported by the Russian President's Grant Council, form the basis of the centre. A world-class laboratory was established within the so-called mega-grant by the Russian government decree number 220, Biogeochemical Cycles of Arctic Maya Lake Landscapes of West Siberia as an indicator of global climate change and a basis for the rational use of natural resources of the region, Bio-Geo-Clim. This lab is supervised by Oleg Pokrovsky, a world-renowned biogeochemist specifically invited by TSU for that purpose. The centre consists of 6 laboratories, including the previously mentioned one, and the Laboratory of Biodiversity and Ecology, the Laboratory of Chemical Analytical Methods of Research and Modelling of Natural Processes, the Laboratory of Radiophysical and Optical Environmental Research Methods, the Laboratory of Evolutionary Cytogenetic, and the Laboratory of Social Economic Research. The centre studies the climate regulation function of West Siberian Mayas and the biodiversity and biogeochemistry of wetland areas. The applied component of studied and modelled natural processes will have enormous social and economic benefits for the region and beyond. Western Siberia is a unique Maya region of the world. Overall, 1 million square kilometers are covered by different types of Mayas. Siberian peatlands have been a major sink of atmospheric carbon since the last deglaciation, and on the other hand, in some periods, like the present, they are the most powerful source of methane emission. The flat relief and presence of horizontal impermeable rocks lead to low drainage intensity and promote intense paludification. In some parts, up to 70 to 80% of its territory is covered by Mayas. The formation of Mayas induces the formation of iron-rich waterproof horizons, which help the Mayas to stabilize and even expand their areas. Among the Mayas of Western Siberia, there is one that stands apart, the Great Vasugan Maya. This is the largest peatland in the world, with a total area of almost 7 million hectares. Stocks of peat deposited by this largest Maya pool in recalculation on absolutely dry organic substances amount to almost 18 billion tons, which is 16.5% of the peat stocks of all Western Siberia. This unique Maya is a natural feature of world value, comparable in importance and rank with Lake Baikal, and in 2007 an application was submitted to nominate the Great Vasugan Maya for the UNESCO World Heritage List. In recent years, the biospheric role of Mayas has become a major issue of concern. One of the most important biospheric functions of Maya ecosystems is carbon sequestration as a result of photosynthesis, its accumulation in peat deposits, and its emission as carbon dioxide and methane. Western Siberia acts as a terrestrial sink of atmospheric carbon and thus plays an important role in the global cycle of carbon. For thousands of years, the vast taiga forest and pristine peatland areas south of the permafrost area have been sequestrating substantial amounts of atmospheric carbon. For millennia, Mayas have sequestrated and accumulated carbon in their peat layers, reducing the levels of carbonic gas in the atmosphere, and thus mitigating the greenhouse effect. It is not surprising that scientists consider Mayas natural sinks of carbon. They have evaluated that as a whole, from 51.7 to 70.2 billion tons of carbon are stored in West Siberian peat mires. That equates to 26% of carbon accumulated by terrestrial ecosystems. On the other hand, in connection with the newest climate changes, the northern mires located in the cryolitha zone of western Siberia became the most powerful and the most dangerous source of methane emission to the atmosphere. It was shown that northern thermokarst lakes are a globally significant source of atmospheric CH4, emitting approximately 24.2 plus minus 10.5 Tg CH4 per year. Figuratively speaking, in the south of western Siberia, the mires play a positive role in climate regulation, withdrawing carbon from the atmosphere, and thus acting as global coolers of the planet, whereas in the north they became a source of the so-called methane threat, but neither the magnitude nor the balance of these processes is sufficiently investigated. In terms of carbon cycle, this tendency will be expressed. Mires will turn from sink to source. Complex research of the Arctic zone, as well as its development, is impossible without a thorough understanding of the fundamental feedbacks of permafrost and climate. Arctic studies, as well as studying the permafrost state in an era of climate instability, is of particular relevance nowadays. This is especially true for the vast waterlogged subarctic areas of western Siberia, which is one of the hotspots of global warming on our planet. It's not surprising that climatic changes here are more dramatic compared with other northern regions, such as Scandinavia, Canada, and Alaska, and changes in permafrost landscapes are more notable due to the severe continental climate. Understanding the climate permafrost system requires knowledge of climatic effects on carbon cycling and greenhouse gas dynamics in coupled land-water atmospheric systems, and in turn, how these feed back into the climate permafrost system. Through feedbacks with climate, permafrost affects many natural processes and phenomena, ecological processes in ecosystems, biodiversity and migration of species, hydrological features and relief of different areas, soil resistance, the indigenous population, and socio-economic issues. Understanding these feedbacks will create a real basis for a comprehensive study of the Arctic zone. Large amounts of organic carbon are stored in permafrost soils at high latitudes. Climate change and the consequent thawing of permafrost cause mobilization and decomposition of these old carbon stocks, and hence the release of significant amounts of greenhouse gases from land to the atmosphere. Permafrost thawing may also increase the lateral export of terrestrial carbon to aquatic systems, altering flow pathways in the landscape. Streams and lakes play here an important role by burying carbon in sediments and emitting it to the atmosphere, and, by that, affect the continental greenhouse gas balance and the amount of carbon delivered to coastal regions. Still, the current knowledge of climate impact on carbon cycling in inland waters at high latitudes is, in many important aspects, incomplete, preventing accurate quantification and predictions of their role in the carbon cycle and climate system. Siberia contains vast carbon stocks potentially vulnerable to mobilization following permafrost thawing, and inland waters draining these regions are largely understudied. Thus, research on inland waters of Siberia is of particular importance for understanding climate change. We will carry out a comparative study of lake stream networks across a climate gradient in western Siberia, covering a large range of permafrost conditions. This research is important by providing knowledge of the role of Siberian inland waters in emitting carbon to atmosphere and in exporting carbon to downstream coastal regions, and how this varies between different climate regimes. Owing to the development of the oil and gas complex, western Siberia, in comparison with other Arctic regions of the planet, has the most developed infrastructure roads, oil and gas pipelines, pads, power lines, gas compressor stations, and cities and towns of oil and gas industry workers. Nowadays, this infrastructure suffers significant damage from the climate impact, accompanied by permafrost degradation, and authorities in the region, together with the largest oil and gas corporations, have to spend huge amounts of money to keep it going. On the other hand, this well-developed infrastructure alone, especially the good road network, provides unprecedented access to the region for research and field experiments, making them significantly cheaper than in other northern regions, which have to make use of small planes or helicopters. Thus, Western Siberia is a key region and the most convenient site for studying both the fundamental questions of interaction of climate and permafrost, and considering the practical aspects of these changes and evaluation of these social aspects. These issues are at the heart of the Centre's activity. We propose an integrated research program which will provide a comprehensive assessment of the importance of interaction of the permafrost climate system for regulation of the carbon cycle in the Arctic and subarctic regions, including carbon exchange with the atmosphere and river export of land-based carbon to coastal regions. The Centre brings together an excellent interdisciplinary team of researchers, each bringing their distinctive expertise to highly integrated research, where they're going to achieve synergy while deploying cutting-edge techniques to advance understanding of the effects of climate warming on the permafrost state, biogeochemistry, hydrology, sea fluxes, and infrastructure. The key researchers are internationally renowned scientists and great organizers of science, organizers of global network consortia, and projects such as Interact, Circumarctic Network of Field Stations, IPA, International Permafrost Association, MRI, Mountain Research Initiative, the International Scientific Association, ISA, of Russia and France, CAR-WET-SIB, the Siberian French Centre for Education and Research's Environment, Biosphere, Climate Change. This ensures widespread dissemination of the new approaches, models and technologies developed in the Centre and their implementation in professional scientific communities. Regular field expeditions to West Siberian wetlands have resulted in a number of implemented projects, scientific publications, and successfully defended PhD and higher doctoral dissertations. A group of Tomsk and French researchers was able to demonstrate that monitoring thermokarst lake dynamics in changing permafrost is extremely important for the prognostic modeling of greenhouse gas emissions into the atmosphere and carbon discharge to inland waters, which is the most serious threat of global warming. The site for studying small thermokarst lakes is located in the central part of West Siberia at a distance of 20 kilometers from the village of Khanimey in a northern taiga zone. This is a very interesting site located in a continental part of a forest and tundra area with typical frozen mound bogs and thermokarst lakes. Fortunately, the area has not been affected yet by the oil and gas producing complex, which is actively developing its infrastructure all over the territory of West Siberia. This is the reasons why researchers have an opportunity to continue work on the studying of the region's impact on the formation of the Earth's climate. In the summer of 2012, a team of researchers including scientists from Tomsk State University and Oleg Pokrovsky, a researcher from the Midi-Pyrenees Observatory, now the head of the TSU laboratory, carried out field research in the thermokarst lake area. The researchers obtained unique results. For more than 3 months, the weather in the region was hot and dry. Air temperatures were 5 to 15 degrees higher than those observed during the previous 30 years. This unusual climate phenomenon provided an opportunity to examine the effects of short-term natural heating of water in thermokarst ponds and lakes, and compare these observations to previous field results obtained when the temperature was normal in the same region. In 2012, thermokarst bodies of water shrank significantly. Water levels dropped approximately 50 centimeters, and shallow soil depressions disappeared. The increase in water temperatures resulted in changes in its chemical composition. In water bodies, a concentrated composition of trace elements and macrocells was generated, and the carbon balance changed. Nature seems to have modeled a situation that might arise under the influence of global warming. In the course of the research, scientists found out that in these conditions, emission of greenhouse gases into the atmosphere rises abruptly. After a series of biogeochemical analyses of thermokarst lakes at different stages of development, researchers discovered that small lakes emit into the atmosphere hundreds of times more methane than large ones, thus strengthening the so-called greenhouse effect. But these small water bodies have not been the subject of research until recently. They are difficult to identify in images, and during studies on location, researchers preferred large lakes, considering them to be more representative of the class. Meanwhile, the number of small thermokarst lakes is estimated to be millions of lakes, and all of them emit great amounts of methane. Despite this fact, they are not taken into consideration in existing carbon exchange models. To take these small water bodies' role into account, one needs new models. The researchers from the Russian-French team are convinced that to continue the research is of vital importance. All over the world, winter ecology has begun to develop as a promising scientific trend. It was also interesting to see how bogged territories look like in winter. Up to now, the scientists have been there only in summer. Bio-Clim-Land Centre arranged a unique winter expedition to the north of western Siberia, starting in February 2014. The researchers collected data for different kinds of analysis. The route for collecting samples crossed the geographical mega-profile from the West Siberian South Taiga landscapes to the Gulf of Ob in the far north. Following the plan, they stopped from time to time on their way to collect samples of water, ice, and snow. The procedure is carried out in accordance with strict rules, such as the remoteness from objects of civilization, roads and bridges, usage of special containers and equipment. Any departure from the requirements may result in getting invalid data for the laboratory research, and the expedition outcomes are supposed to have a great influence on the current conception of the landscape dynamics and biogeochemistry under global warming. The fieldwork is starting. The expedition participants go to the site for collecting samples. Some of them make a snow survey to assess the depth and density of the snow cover using special measuring tools. With the help of a titanium ring drill made especially for the expedition at a defense plant to provide sample purity, the scientists start cutting out a core from the lake ice thickness. Taking turns, they try to drill, but it is not an easy task. Its knives break down because the ice on northern lakes is heterogeneous, with layers of sand inclusions. When a water body freezes, the water under the pressure of permafrost from below splashes many times on the ice surface, which is the reason why the core of the sampled ice looks like a layered cake, consisting of layers of ice and sand. Coming into contact with it, any tools, even titanium ones, break down. The short day comes to an end, and the scientists return to the hotel. The work has not yet finished. In the evening they will pack the samples to be sent not only to Tomsk, but also to Toulouse for a thorough biogeochemical analysis. The scientists collect the data not only for the laboratory under the guidance of Pokrovsky. Apart from 64 points of sampling water and ice, they also check the data of satellite altimetry and collected frozen peat monoliths for experiments in the laboratory. They collected conifer needles for their colleagues from the Institute of Monitoring the Climate and Environmental Systems of the Siberian branch of the Russian Academy of Science. Pollution samples for chemists from TSU, and searched for stardust, which the comet that passed by the Earth some time ago might have lost. The data obtained will serve as a basis for scientific publications in world-class journals. The researchers are sure that it is going to be a real breakthrough in the field of biogeochemistry and landscape ecology of Arctic ecosystems. In recent years, mechanisms of multilateral collaboration and opportunities to take part in large complex programs have been developing fast. The collaboration of Tomsk researchers with their colleagues from abroad, lasting for many years, implementation of several international projects, and rising interest in bogs on the part of French, Polish, and American colleagues and researchers from other countries confirm the necessity of creating a permanent research station in the region. Now the researchers have every opportunity to do it. A large international project, in accordance with Government of the Russian Federation Decree No. 220, was implemented in Tomsk State University, a world-class laboratory organized under the guidance of Oleg Pokrovsky, which will be specializing in the studying of a climate-regulating role of the West Siberian wetlands. A new station will make it possible to expand the range of research, provide for researchers' mobility, and the training of specialists in this field of science. Observation, monitoring, experiments, and modeling will be supported with modern technologies, specification of composition, and monitoring environment parameters using GIS technologies. This is only one of the projects. Tomsk State University has experience in organizing stations of this kind. For more than half a century, a research station has been working in the Altai Mountains in Aktru Valley. Both Russian and foreign scientists work here. Students of various majors, botanists, ecologists, hydrologists, have practical training sessions at the station. Every year, large scientific events are held here. The most famous is the International Aktru Summer School. The station's infrastructure is being improved constantly. In 2011, Aktru Station was included